Welcome to VQ Intel. In today's video, we're going to be talking about function transformations, specifically stretches and shrinks to a function. If you want to follow along, there's a link down below in the description to this companion worksheet so that you can print it off or just view in PDF form and follow along. Now, in a previous video, we talked about shifts with function transformations, and that link is up in the right-hand corner right now if you want to go look at that first. Now today we're following that pattern where now we're going to be multiplying and dividing. And so what happens is now when we multiply, that's going to cause one effect, and when we divide, that's going to cause another effect. So here I'm multiplying before I apply the function. What that does is it shrinks f of x horizontally by a factor of c. Now in other words, we take the x values and divide them by whatever c is. Or here, I take x, divide by c before I apply the f function. That means I'm going to stretch f of x horizontally by a factor of c. Or in other words, multiply the x values by c. Here, if I'm multiplying after I apply the function, I'm going to stretch vertically. That is, multiply the y values by c. Or if I divide by c, I'm going to after I apply the f function, I'm going to shrink f of x vertically by a factor of c, or just divide the y values by c. So when we change x before we apply the function, that's going to change the x values. It's going to change it horizontally. If I make this change after I apply the f function, it's going to change vertically. That is, it's going to multiply the y values by something. And this is the same thing that happened with the shifts. If it was on the inside of the function, you change x. If it's on the outside of the function, you change y. And when you change the inside of the function, you do the opposite effect. So here we're multiplying. It says f of c times x, but we actually divide. Here, f of x divided by c, we actually multiply. So, as with that video before, we're going to use this graph to draw some functions here. So, here we have g of 2x. So what this means is we are going to divide x by 2. So every x value on this graph is going to get divided by 2. So here -6 is actually going to be -3. So -3, -3. I'm going to leave the y values alone. Here, -5, -2, so that's -2.5, 2. -3, 0, that's going to become -1.5, 0. 0, 3, if I divide that by 2, well, 0 divided by 2 is still 0, so that point doesn't change. Next point up here is 2, 4, so that's going to become 1, 4. 4, 3, when I divide that by 2, that becomes 2, 3. 6, 0 becomes 3, 0. 8, -2, that's 4, -2. 10, 0 is going to become 5, 0. And then 11, 1 is going to be 5.5, 1. So there's what this graph looks like. So this got shrunk, or in some books they'll use the word compress. It's different language to communicate the same idea. We're taking this graph and we're compressing it this way, and that's what happened. Now here we have g of x divided by 2. So what's going to happen is we're going to multiply x by 2 because we do the opposite. So all the x values are going to double in scale. And actually, if I look at my graph, my smallest x value is going to be -12. My biggest x value is going to be 22. So how do I handle this? Well, I'm just going to scale my x's a little differently. I'm going to scale them by 3. So 3, 6, 9, 12, 15, 18, 21, 24. Now, that means that 1 and 2 are going to be in between here. And so I'm going to have to do a little bit of guesswork, but at least this way I'll be able to fit the entire graph. Now, some teachers say you just fit whatever there is from -10 to 10, and if your teacher says that, do that. You're not going to see the whole graph, you're only going to see a part of it. So over here, this is -3, -6, -9, -12. All right, so this becomes -12, -3. This is -10, -2, so right about there. This is going to be -6, 0. This is still going to be 0. Now I'm not changing the y values, just the x values, because they don't need to scale. They're not changing. 2, 4 is going to become 4, 4. 4, 3 is going to become 8, 3. 6, 0 is going to become 12, 0. 8, -2 is going to become 16, -2. 10, 0 is going to become 20, 0. And then 11, 1 is going to be 22, 1. Now again, all we're doing is stretching it out. So it's going to be more or less the same shape, but it's just going to be pulled outward like that. All right, next one. Here we have 2 after we apply the g function. So that means we're going to multiply y by 2. Because when it's outside the function, we do as it says. All right. So here this is going to become -6, -6. This is going to become -5, -4. This is going to become -3, 0, because when we multiply the y value, that's still going to be 0. I have 0, 3, that's going to become 0, 6. Over here I have 2, 4, that's going to become 2, 8. 4, 3 is going to be 4, 6. 6, 0, well, y value of 0 is still 0. 8, -2, that's going to double to -4. 10, 0 is still 10, 0. And 11, 1 is going to become 11, 2. So what happened? This graph got stretched this way, up and down. All right, so here g of x divided by 3, so we're going to divide y by 3. So -6, -3 is going to become -6, -1. -5, -2, that's -5, -2/3. -3, 0, the y value is still 0, so that's not going to change. 0, 3, that's going to be 0, 1. 2, 4, that's going to be 2, 4/3, so that's 1 1/3. 4, 3, that's going to be 4, 1. 6, 0, 0 stays 0. 8, -2, that's going to be 8, -2/3. 10, 0 stays as is, and then 11, 1 is going to be 1/3. So this graph is really hard to see because it is so close to the x-axis, because all the y values got compressed this way. So that's what happened there to that graph. Right. So now here we have these functions, and now we want to state how it was transformed. Now here we're talking about multiplying and dividing. So here I'm multiplying by 2 after I squared. So that's my parent function, x squared. Now I'm multiplying afterwards, so that means I multiply by 2. So that means I'm going to stretch, or expand if you prefer that word, vertically by a factor of 2. Next one, here I've got sine of x divided by 4. So if I isolate that, what's left? Sine of x. So I'm going to multiply x by 4. So that means I'm going to shrink sine of x horizontally by a factor of 4. All right. Now, next one, I'm multiplying by 0.5 both inside and outside this function. So if I take out those 0.5s, what's left? Square root of x. So here, this inside means I'm going to divide x by 0.5. Now, that's kind of awkward. And so for some people, they'd prefer to think of it like this. I'm going to multiply x by 2. They're the same thing, but people have a hard time with transformations that have decimals, especially when we multiply. Now over here, I'm going to multiply y by 0.5. Now that's the same as divide y by 2. Again, getting rid of the decimals makes it a little easier to see. So what's going to happen is two things. We're going to stretch the square root of x horizontally by a factor of 2. And we're going to shrink vertically by a factor of 2. All right, now the last one here, we've got 1/4 out front, and we've got 3 on the inside. So what's left is ln of x. Whatever that is, not quite sure, but you don't have to for this. So if those of you familiar know what ln is, great. And if you don't know what ln is, that's okay too. You can still complete this without knowing what ln means. So here, the 3 means I'm going to divide x by 3. And here, I am multiplying y by 1/4. But again, some people don't like the fraction, so instead you could say divide y by 4. Same outcome. And so what's going to happen is if we're dividing x and dividing y, then what that means is we're going to shrink ln of x horizontally by a factor of 3 and shrink vertically by a factor of 4. Okay. Now for the last one, here we've got these parent functions in the dotted, and we want to write the transformed functions. Now again, we're using stretches and shrinks, so we're talking about multiplying and dividing. So this function right here is only on the right-hand side, and that's because this is square root of x. It only has a domain in the positives and 0. Now looking here to here, we ask, all right, the x stayed the same, but the y got multiplied by 4. So that means it's going to be 4 square root of x. That's going to be this one. Over here, the dotted is the parent function. This is x squared. And so looking from here to here, the x stayed the same, but the y went from 4 to 2. So that means I multiplied y by 1/2. So I could either say 1/2 x squared, or I could say x squared over 2. Algebraically, they're the same thing. And so some people prefer just to do multiplying. Some teachers don't like dividing at all, and if your teacher is that way, then that's fine. They made that choice, and you just are going to write it like this. Down here, our parent function is this, absolute value of x. Now notice both the x and the y changed. The x got divided by 2. So that means it's going to be 2x on the inside, and the y got multiplied by 3. So that means we put a 3 on the outside, like that. Over here, same parent function, absolute value of x. Now, x got multiplied by 4. So I'm going to do the opposite. X divided by 4. But the y got divided by 2. So we can divide by 2. Now again, if your teacher doesn't like dividing, then you could write it this way. 1/4 x with a 1/2 out front. Thanks so much for watching. If you want to support the channel, make sure to click that like button and check out the links down below. Remember, the best way to understand something is to do it.